Dam significance is imperative for the prosperity of Pakistan and fulfill the water requirements for agricultural and power. Tarbela and Mangla multi-purpose mega projects sustain Pakistan's agriculture economy by supplementing and regulating irrigation supplies and providing cheap energy to the country. Since Pakistan has started the construction of Momin Dam and announced to commence the Diamir Basha Dam. On completion, the thousands of megawatts and millions of acre-feet water storage will be available. However, the cascading hydropower projects also playing vital role to mitigate the shortfall of electricity in the country, and Balakot HPP is one of the cascading hydropower project ready for construction. The 300 megawatt Balakot hydropower project is one of the series of hydropower project on Kunhar River launched by Pakhtunkhwa Energy Development Organization, Government of Khyber Pakhtunkhwa. The objective of the proposed hydropower scheme is to generate and add cheap energy to the system in order to meet the current shortfall and increasing demand of electricity in the region through economical and sustainable means. Balakot hydropower project is located on the Kunhar River, about 18.6 kilometers upstream of the town of Balakot in KPK province. The project is expand and 12 kilometers from Paras to Sangar village. The dam site will be located near the village of Paras, whereas powerhouse site will be located 8 kilometers upstream of Balakot, near Kapi Gali village. The run-of-river scheme was originally identified under the Study Identification of Hydropower Potential in Kagan Valley by the Sarhed Hydel Development Organization, now called PETO, with the technical collaboration of the German Agency for Technical Cooperation, GTZ. A feasibility study of the project was prepared in 2013 and updated recently by reputed consultants. Joint venture comprises of Aqualogus from Portugal, Team Consultants and Zurich International from Pakistan. The consultants was released a draft report of their findings in 2018. Hagler Bailey Pakistan, Private, Limited, contributed to the environmental and social assessment of options for ensuring that the project meets the environmental and social safeguards. The 58 meters high dam structure is concrete gravity with a curved axis in plane and a radius of 187 meters. The dam crest elevation is 1292 meters above sea level and the crest length is approximately 130 meters. A crest width of 8.5 meters is proposed to ensure adequate access for vehicles, cranes and other maintenance equipments. It has been designed to pass floods of 3,500 cubic meter per second, with an upper gated OG crest spillway and a low-level gated spillway. This layout consists of 3 radial upper spillway gates, having an opening of 11 meter height and 10 meters width, as in 2 low-level spillway sluice gates of 8 meter height and 6 meter width. The gates are hydraulically operated for flood discharge and are set at the crest level of 1,252.5 meters above sea level. The river diversion scheme consists of a right bank diversion tunnel which will be further converted to a sediment bypass tunnel as well as additional openings in the dam body for the low-level spillway. The dam will create 2.2 kilometer long reservoir with a gross storage of 3.6 million cubic meter at the maximum operation level, 1288 meters above sea level. The proposed reservoir falls mainly in the residential area of Paras town, starting from just downstream of Tailrace area of under construction Suki Kanari hydropower project. During filling, hundreds of residential and commercial properties will submerge in the reservoir on the terrace deposits of Kunhar River. The headrace tunnel extending 9 km will divert water from the reservoir created by the dam to the powerhouse. It is designed on the left bank of the Kunhar River, having internal diameter of 8 meter, which will passes through highly tectonic zones in the Murray Formation. At the end of the headrace tunnel, surge shaft is designed to mitigate the water hammering effect in case of sudden shutdown by closing the turbine valves. If no arrangement has been made to prevent this water hammering, it may result in bursting of penstock pipe and may lead to serious stability issues. The construction of surge shaft is recommended by the raise boring method and expansion of shaft after raise boring is designed with drill and blast method. Initially the pilot hole shall be drilled and then re-aiming process shall follow from bottom chamber and in the end, expansion of shaft and concrete lining be made. The surge shaft is 122 meter high having internal diameter of 14.5 meter, steel lined pressure shaft having length of 152 meter shall feed powerhouse. The BHPP powerhouse is proposed on the left bank of Kunhar River near Kapi Gali village, under the rock cover of 230 meter. The underground powerhouse is composed of 2 conventional cavern structures for 3 identical Francis units with vertical axis and for the power transformer and GIS equipment. The main hall of underground powerhouse shall be 71 meters long, 20 meter wide and 34 meter high. The transformers cavern shall be 88 meters long, 14 meter wide and 15 meter high. The access tunnel is arranged for main powerhouse and transformer hall. During construction it would be used for excavation activities and during operation for access of O&M personnel. The Balakot hydropower project caverns would be constructed multi-story structure like other underground complex. The excavation is recommended with conventional drill and blast method. The excavations of underground caverns shall be done layer-wise with controlled blasting. 1.6 km long tailrace tunnel having internal diameter of 8 meter is designed to drop the water into Kunhar River after feeding the turbines. The living facilities necessary during construction and for operation maintenance, temporary and permanent staff residential colony, would be constructed with all allied structures such as office building, rest house and staff houses. The exterior switch yard is arranged on the banks of the river, near the powerhouse access tunnel, from where power will be evacuated to the national grid. Out of 3 generating units, 2 will be connected to 500 kV grid, and 1 unit will be connected to 132 kV grid to supply local grid of the Balakot area. The project will provide 1,250 GWh average annual energy in the system. It is expected that construction will commence very soon, as the Paktunkwa Energy Development Organization, with the collaboration of Asian Development Bank for financing the $645 million, has already initiated the bids process for the selection of consultants and the main contractor to implement design, supply and installation, testing and commissioning of Balakot hydropower project. The construction period of the project is 75 months. Thanks viewers for watching and thumbs up if you like. Write us in the comments section and subscribe our channel for more updates.